All right, so for this one, I want to talk to y'all about maximum height. So a toy rocket is shot vertically into an air from a launching pad 2 feet above the ground with an initial velocity of 176 feet per second. The height h in feet of the rocket above the ground at t seconds after launch is given by the function. How long will it take the rocket to reach its maximum height, and what is the maximum height? So the first thing we want you to notice with this is the function itself. The highest exponent is 2. That means it is a parabola. Okay? If you look through all the words, this 2 feet above the ground, that's already in your equation, so you don't have to worry about that. This 176 feet per second, that's already in your equation, so you don't have to worry about that either. Okay, so these are already accounted for. We don't need to worry about those. What we want you to see is that this equation is a parabola. Because the leading term is negative, that means it's going to be a parabola facing down, opening down. That means the vertex is going to be the maximum point for it. It's going to have a maximum, not a minimum. So when it asks for the maximum height and the time to get to the maximum height, so I guess this was the time. And then you've got the maximum height over here. All it's doing is it's asking for the vertex. What is that maximum value? The x value is going to be your time, because time is independent and x is always your independent variable. Your height, it's going to be the y value of the vertex. So your vertex is going to be in time, comma, height. So once you get your vertex, then you can read what the pieces are. And it makes sense if you think about it in a picture. So if we were to have a toy rocket, and it was going to shoot up, and its launching pad is 2 feet above the ground, and it's going to shoot up, and it's going to eventually come back down, because what goes up must come down. The highest point here, that's your vertex, that's your maximum height. Then if you think of it on a graph, your height would be the y value, because that's how tall it got. And your x value would be your time. Okay, so all we're going to do is we're going to take the equation and we're going to find the vertex of the equation. To find a vertex, you need a formula, x equals negative b over 2a. Your a, b's, and c's, they come from your original equation. Be very careful to make sure you have the correct a, the correct b, and the correct c. A is always the coefficient of x squared. B is always the coefficient of x. And c is always the constant. Now I know we don't actually have x's, but it's the same thing. T squared, x squared would be your a. T or x would be your b, and the constant would be your c. If you did not have a term without an exponent, so you only had a and c, your b would be 0. Be very careful with those. Okay. So then we're going to plug it in. X equals negative 176 divided by 2 times negative 16. We grab our calculator. It's going to give us 5.5, 5.5, 5.5. Now that's my x value. So that's going to be my time. So our time, it told us, was in seconds. So 5.5 seconds for the rocket to reach its maximum height. Okay. To find the y value, you are going to plug in your time, plug in your x, your t. So I'm going to go back to my original equation. I'm going to zoom in a little so we have some extra room. All right, so my equation was h of t equals negative 16 t squared plus 176t plus 2. So instead of t, I'm going to put 5.5. And then I'm just going to plug it in my calculator. You get 486. Okay, and then you need to get your units. So let me go back to my original problem. Our h was in feet. So feet. So our maximum height occurred in 5.5 seconds at 486 feet, in case you needed that in a sentence.